Crushed it.
Crushed it? Okay. So who wants to share your solution?
I do.
Brittany, what's your solution?
Should I post it in Slack or should I just start it?
No, I actually want you to, yeah.
Okay, so I have a function called letter counter.
Okay, I'm going to call it Brittany count.
It accepts a string as an argument.
What did you call your argument?
String.
Okay, I don't think that's a reserved word in Python or in JavaScript, so we're good. Okay.
So then I declared a variable called letters.
Let or const?
Const letters equals string dot lowercase dot split with single quotes in the,
like that? Oh, no.
Space.
No space? Okay.
And then beneath that, declared a variable const symbols. It's an array, and it has space in quotes, and then comma, period, I did it for comma, dash, semicolon, colon, exclamation point, and question mark, which may be overkill. Assignment, but whatever.
Okay.
And then I declared an object called counter, so let counter equal.
Oh, let, okay.
Equal.
Curly braces?
And then I iterated through letters.
How'd you do it?
So I said letters for each letter. Error notation. So you put letter in.
Oh. Okay.
And then if not, symbols dot includes letter. Counter letter in parentheses, or you could do counter dot lettering. The counter letter in brackets.
Okay.
Equals 0.
Okay.
So when that goes, it'll make an object with the letters as keys and then 0 as value.
Okay.
And then beneath that, I iterate through letters again, and I say, and maybe this is redundant.
Down here, like letters.
Yeah. For each element, if you use letters by each element. If not, symbols dot includes element. Counter bracket element plus equals 1.
Okay.
And then at the very bottom of the function, just a log counter, or calls for log counter.
Okay. What do you guys think?
I think that it's like a lot of iteration and stuff, and like I didn't finish mine, but like the logic that I was trying to follow was to use regular expressions to remove any of the symbols.
Okay.
And then when you create an object, this is where I got stuck, but I'd done it before and I just needed to find a way to do it. When you create an object, there's a way to just like add a key value pair into the object. And so like we just kind of like iterate through the string and then like add to the value. Like I've done it before and I just like couldn't remember exactly like I was trying to follow the logic of it. But I think that like I totally see like where the logic came from Brittany, but I feel like you're just like iterating and iterating and iterating, and there's like probably a way to do it that's less of that.
Kelsey, what do you got?
Well, I think I did kind of what she's talking about.
Should we type yours out?
If you want.
Oh, I want. All right. What did you call your argument?
Letter count.
Perimeter.
Oh, my arguments?
Yeah.
String.
Popular. Okay. So
Const LC string equals, just lowercase string is LC string, my variable for it. And I did equal string.
Okay.
And then let's tracker equal empty brackets.
okay. We can do a const, by the way. Unless you ever are going to do another tracker equals, you can do a const.
I kind of might, but
Oh, okay. All right. Well, we'll do a let for now. Okay.
So in here I just did this for loop starting at I equals 0. Semicolon I less than string dot length, semicolon I plus plus.
Okay.
This is old style, but it's the first thing that pops into my head.
Yeah. Better to get it done and optimize later.
Yeah. And next line is if tracker, and then open bracket. Yeah, or LC string I.
Okay.
Does not equal, and then this is where I would have put the regex.
Oh.
But I just put in, since I only saw white space in the period, I put in,
okay.
Doesn't need. And then next line is if tracker, LC string, bracket LC string I, and then that's, and then at the end of the line, open the bracket, curly braces, and then here I add, I just add 1 to, I'll speak it out actually, tracker, bracket LC string I plus equals 1.
Okay.
And then else, and tracker LC string I equals 1.
Tell me about this logic here, Kelsey, from line 23 to 27. Tell me what you're actually doing there in like words.
So I'm checking to see if I've already got that letter in my object in tracker, and if it's there, I'm just adding 1 to the count that's already there.
Okay.
The next line is adding the count of 1 if it's the first instance.
If it's the first instance, you set it to 1.
Yeah.
Otherwise, you add 1.
Yeah.
Does that make sense to people? This is a classic way to use objects to count things.
Wow, I did the classic.
You did the classic. You did the classic. Brittany, off the beaten path.
So in my solution, I could, instead of iterating through once and setting everything to 0, and then going through twice and setting it to 1, I could get rid of that second for each statement and integrate what Kelsey did.
Exactly.
Yeah. And just do, if it doesn't exist, set it to 1.
Exactly. Yeah. I like the idea of using a regex. That's great because then you can just say what you want to include. Numbers and letters, right? Or did they say numbers? I don't know. Just letters?
Just A through Z.
Just A through Z.
And I did try it, but it didn't work. So
what would be the regex?
Let's first of all, I need to look at how you do regexes in JavaScript because I have not memorized that. What would you guys search for if you wanted to know how to do regexes in JavaScript?
I did the string as a capital. What I did is a string dot replace capital W. I just went and searched all the characters that weren't.
Oh, yeah. Okay. So what Jonathan did, he used regexes to say string dot replace anything that is a non-word character. That's what this capital W is.
I did a plus below.
Right. And all of them, not just the first one, but all of them. That's what the G means. And you probably just replaced it with an empty string. Let's take a look at that. That's awesome. So let string equal, node. let string equal hello world, how are you today? And now if I do string.replace, very nice. Check that out.
So I took away all the spaces and I took away the punctuation.
Anything that wasn't a word character.
Mm.
And word characters, I think, are letters, numbers, and I think underscore is a word character as well.
White space as well. It takes out the word.
Yeah, so white space is not letters, numbers, or an underscore. Anything that's not letters, numbers, or an underscore is covered by this umbrella. What else? What else did people come up with? Let's talk just a little bit about, okay, so we can say, so now we can do the Kelsey-Jonathan merge model, and check that out, right? We can chain those. And then you never do reset tracker, so I'm going to make that a const. You do tracker like this. To make this a little cleaner, I think the best way to make it cleaner, and again, like, I don't want to detract. Kelsey, you got the job because you came up with a solution even though it wasn't perfectly clean, right? The person who sat there thinking, oh no, there's a better way that I could do this, there's a better way I could do that person did not get the job. So, but let's do lc string dot for each letter, and then we can just say if, oh, we don't, yeah, we can just say if tracker letter, then tracker letter +1, otherwise. And because I'm such a big ternary fan, I would probably write it like this. Actually, this is even better. No, I think we'll do that. Otherwise, okay. All right, and so now got that.
Okay.
And then we always want to have some way to get that out so we could return tracker. What's the runtime?
Right.
And squared,
Why?
because you got that 4 each, and that's about it. Oh my God.
N squared. So N squared would mean that inside the for each, what I was doing depended on the number of letters. Certainly the number of times I do line 22, the number of times I do line 22 depends on the number of letters.
Right.
Is line 22 constant, or does line 22 itself depend on the number of letters?
It depends on the number of letters.
Why?
Because the string is variable. So
But we're taking care of that. We're only looking at one letter here. We're not looking at all the letters here. We're just looking at one.
21 would be the, no?
What do you mean? 21 definitely is O of N. 21 is linear. That is going to depend on the number of letters. It's going to be very different to do this for a 1-letter string than for a 3 million letter string. Right? But 22, does 22 depend on the number of letters? The only reason 22 would depend on the number of letters is if it depends on the number of letters to determine whether or not tracker letter is undefined. Does it depend on the number of letters to determine whether or not tracker letter is undefined?
I don't think so.
Yeah, let me ask you this. If I asked you if tracker was an array and I asked you whether or not letter was in that array, would that depend on the number of letters? Yes. Right? Because you need to look at every element in the array, and worst case, all of your letters ended up in the array. Checking to see whether something is in an array is on the order of the length of the array. However, objects are trickier. Objects are stored in memory in such a way that this is a constant operation. This is constant runtime. But that's not a given. That's something that you need to know.
What does that mean when you say that?
I mean that it doesn't matter how many letters are in tracker. If tracker has 3 zillion letters, or if tracker has 1 letter, this is going to take the same amount of time to determine whether or not for any given letter it is defined or not. That's something actually pretty cool about objects. Objects are super runtime efficient.
I'm still trying to understand runtime.
It's going to be a lifelong project.
Okay.
Yeah.
Thank you. Thank you for telling me.
Yeah.
Like
Okay.
when you first asked, I was like, I remember us talking about it last week. But I can remember what things you would need to know.
Yeah, you just want to know, does it depend on how many letters? In this case, n is the number of letters. Does it depend on how many letters? This, absolutely.
Right.
This, no. So it's O of n. We are doing a constant runtime thing n times.
Got it.
If we were doing an n runtime thing n times, that's when you get n squared. But we're doing a constant runtime thing n times. What about Brittany's?
What's the runtime?
What's the runtime of yours, Brittany? People have guesses?
Squared,
Why do you think that, Sabrina?
because she was iterating twice.
Ah, she was iterating twice, but one after the other. The thing inside, it doesn't matter if you iterate twice, then it's just 2n. It's only if you are iterating and then every time, for every iteration, you're doing n things. Here, we're doing n things once, and then we're doing n things again. This is a worse O of n, but it's still O of n. Oh yeah, no, I'm here for you, Brittany. What about this? I said that that if you're looking for something in an array, that's O of n.
But that has to look over the whole.
Looks over the symbols.
It looks over the symbols. So it does not matter whether your given string has 1 character or 3 million characters. This is going to take the same amount. This does not depend on the number of letters in your string. It depends on the length of symbols, but the length of symbols is constant.
We're gonna have to keep having more conversations.
Exactly. That's why we have Algonauts every day, right? So that we keep on going over this and over this and over this, and hopefully every time we talk about it, it'll sink in just a little more.
So I changed it so it just runs through for each once.
Mm-hmm.
But would that half the runtime?
No, because we don't care about constants. So this is O of n.
This is O of n.
It's just O of n. It doesn't matter how many times you go through n steps.
Yeah.
As long as each of those n steps is constant, it's O of n.
That's O of
Yeah. So yours was O of n plus O of n, which is O of 2n. But but constants like this go away.
Right.
Right? Because it's not like you add up. Oh, you did one thing here, and you did one thing here, and you did one thing here. As long as they're all constant, we don't care. Runtime is about how it scales.
Okay. Wait, so then what's the so what's the runtime of the second solution?
O of n. Right?
So it's the same.
They had the same runtime. Like I said, yours was a less efficient O of n, but it scaled exactly the same as this one.
So runtime is not related to efficiency, it's related to scalability.
Absolutely right.
Ah.
This, by the way, is also O of n. It's going to take O of n to look at every character, see whether it matches, and replace it. So you could call this one O of n plus O of n also. But it reduces to O of n. Yeah, Sabrina.
So I have a question about how objects, no matter how many are in the object, the runtime is the same. How is that?
How is that? Objects are what's called a hash map. And basically you know what, objects are not implemented as a hash map in JavaScript. They're implemented slightly differently, but I'm just going to talk about them as though they were a hash map because the idea is the same. When you look at the key, it hashes it. It does like some mangling of the string that tells you exactly where to look in memory. Exactly where to look in memory for the value. So it doesn't have to it doesn't have to go through the whole thing.
Okay.
Yeah, hash maps are strange and wondrous creatures. Yeah.
I just remembered Judy's
Friend? Yeah.
Yeah,
Yeah.
was talking. I'm like, "What's a hash map?" Well, I may as well look it up now. She's saying to look it up. Okay, so thank you.
Yeah.
Got it right back around.
Also, I just want to say one last thing before we go. Brittany mentioned that she could do counter dot letter instead of doing the brackets. You guys cool with that? Why are you shaking your head, Kelsey?
Because it'll look for a key name letter.
Right.
It'll look for a key that is the string letter. Counter dot letter.
Ah.
And it does not. You guys see that? Cool.
Sorry. I'm delayed.
Okay. All right.
Counter letter equals counter letter, but not counter letter.
Yeah, I know. Try saying that. Try and explain that to somebody out loud. It's because, so if letter, counter dot letter is going to be this, but this
Value and property.
Okay, I can see that. That makes sense.
This is subtle, definitely. Lines 33 through 35 here. right? This, you're substituting letter with whatever it stands for. This one, you're using the literal string letter.
So I'm not working on like algorithm problems. And I'm starting to understand like how you would check to see if something is scalable by looking at the runtime.
Yeah.
What are things to consider when creating solutions to determine whether or not like how the efficiency of your solution compares to like other ways you could solve the problem?
Oh, that's just, I would take a look at your code and see whether anything can be consolidated, right? Whether anything feels like it's unnecessary. Yeah, exactly. Yeah. Yeah, Kelsey?
So just to see if I understand, in this one, it would also be 4 or O of 4n because it has to.
Well, this, it would kind of be 3n. Well, it would be 5n, I suppose, like, because there's one action that's O of n, and then this, you do this n times, and then you do this n times, and then you do this n times, and then you do this n times. But you can think about it, maybe this is not O of n, maybe this is O of 8n, right? You know, and so like that's why the numbers just don't, like the multipliers just don't really make that much sense when it comes to talking about runtime. How do you really determine what is an individual constant action? Yeah, but good way to think about it. You want to look at every line. Is this line constant? No, this line is O of n. Is this line constant? Absolutely. Is this line constant? Yes, right? And so you want to look at every line and think about that. Cool. Wow. Way to do the time. Raise your hand if you